Hey everyone, this is the 7th video of my spacetime diagram series, and today's video isn't really a concept question, but a question about solving a hard question. A video about solving a hard question. So I hope by watching my videos from video 1 to video 6, you're more confident regarding your theory of spacetime diagrams. So now it's time to apply it. So I'm gonna walk you through this question 10. So first, read the question. Okay, so let me highlight just the important parts. So this is the coordinate where we first emit light. And this is the coordinate of our rocket. So because obviously light is something that's gonna be traveling, our first instinct is to draw a world line, right? But then all the world line of light that we're very used to, it looks something like this, 45 degree. But then if we draw this 45 degree angle photon world line, we see that there is no intersection. There's no possible thing that we could do with this world line. So what we do is, I think I briefly mentioned in one of my previous videos, but when you're drawing the world line of light, it doesn't always have to be that 45 degree line that we're all very used to. Matter of fact, it can look something like this, where this is a 45 degree angle. And the key difference between this photon world line that I have in blue and this photon world line that I previously drew, the 45 degree right over here that we're used to, is that this green photon world line is the world line of a photon traveling away from the origin. Whereas the blue photon world line over here, it shows a photon traveling towards the origin, because you can see that the light is initially really far away and then it gets closer and closer and closer to the origin. Like over here is let's say this is a distance between the photon and the origin at one point, and you can tell that this distance is getting shorter as, light approaches. Light follows this path. And now there is an intersection. There's something we can work with. Great. So we drew the world line of a photon. And now we gotta find where the coordinate, at what time does the light reach the coordinate of the rocket? Okay, what is the position of a rocket here? Rocket is original. Oh, this dot, according to this line, it says the dot on the world line denotes the passage of 1 year by rocket clocks. So this is 1 year. Okay, and the intersection that we're looking at is this one right over here, right? So first, in rocket observer's year, what is the time coordinate of this red intersection point? That's like 0.9, 0.8. So already we can eliminate 0.75 and 0.75. We know that it's either B or D. Now, the hard part is, remember time dilation? So we know that T primed equals 0.87 years. Then how do we find T? Try. If you don't know, look back to the time dilation video. What you do is you get a ruler that's the same angle as your x-axis, not x primed, the x-axis, and you extend the line from this event on the moving reference frame that you're trying to find the t coordinate to. And we get t equals 1. So t equals 1 year. So we can say the answer is B.